Right then, so this is quite a long video lesson for nonlinear simultaneous equations. So we've got two simultaneous equations to solve. We've got y equals x minus 1 and y equals x squared plus 2x minus 7. This first one we call a linear expression or equation. Okay, so we just write that keyword underneath it. So you need to know what a linear expression is. Okay, I'll explain in a few minutes now. And the other one, the quadratic one, we call that a nonlinear equation. Okay, now if you pause the video for a second and load up your Desmos app and draw those two graphs, you should get this. I'm sure you all did pause me then, didn't you? You got your quadratic graph there in blue. This is the nonlinear one. It's nonlinear because it's a curve basically. Alright, linear graphs are straight line graphs. Okay, and just as a reminder, when we're solving a pair of simultaneous equations, what we're actually looking for is these 2 points of intersection here. Okay, now when you've solved two linear simultaneous equations, they only cross each other once. Now when you've got one curvy graph, it means they actually cross each other twice. So in these kind of questions, we're going to get two answers. So that would be one of our answers, and that coordinate there would be our other one. Okay, so our solutions here would be, if we read up from there, that would be x equals minus 3. So x equals minus 3, and x equals, if we use the other one, just drop straight down, it is a 2. Now we're looking for pairs of solutions here, so we're looking for x values and y values that solve these simultaneous equations. So we need to just read off the corresponding y values as well. So if that x equals minus 3, y would be equal to minus 4, when x is equal to 2, we get y is equal to 1. Now it's important those are paired up together in the correct order. Okay, so it's a good idea to write our answers for these simultaneous equations like you did at year 10 as coordinates. So our coordinates at the points of intersection are minus 3, minus 4, and 2, 1. So that would be our solution to the simultaneous equations. Obviously, we don't want to draw a graph each time. So we'll now look at an algebraic method to solve a pair of simultaneous equations, where one of them is nonlinear. Okay, so we're going to look at the same questions as we did in the last slide. We're going to solve y equals x minus 1 and y equals x squared plus 2x minus 7 using an algebraic method. So first things first, I'm just going to write the two equations underneath each other, as you'd have done with simultaneous equations in year 10 and year 9. Okay, now I think actually these types of simultaneous equations are a lot easier to solve than the ones you've done in the past, because there is only one method you can use. In the past you've had the substitution method or the elimination method, and you can choose which one is best. Where you've got one of the equations being a nonlinear equation, it's the substitution method. It's the only one you can use. Okay, and what we do is we get an expression for one of the letters from the linear equation. So we got y is equal to x minus 1 in that first one. Okay, so we can take that x minus 1 and replace it where y is in the second equation. Okay, so we'd end up having x minus 1 is equal to x squared plus 2x minus 7, because we're going to replace that y with this. Okay, also you can think both things are equal to y, so therefore x minus 1 must be equal to x squared plus 2x minus 7 as well, because those both expressions are equal to y. So that's how we set up an equation with just x in it as the unknown, and we solve that then. Now, this is an A-star topic, so the examiner is going to be expecting you to notice that you've got a quadratic there. Okay, all right? So this is the equation we'll solve now. So the fact that it's got an x squared term in it tells us it's a quadratic. And then you need then to come to the front of your brain the methods you know how to solve quadratic equations, which we were looking at last week. All right. So the first thing we're going to do is group all this together on the one side, so we have an expression equal to 0. Okay. So if I take the x and the negative 1 across the other side, I'm going to get 0 is equal to x squared plus x. So I'm going to do 2x minus x, and then minus 6. So the x is going across, so 2x minus x is x. And the minus 1 is going across, so minus 7 plus 1 is equal to minus 6. Okay, so there's our equation. I'm just going to rewrite that out. So I've got my x's on the left-hand side, so it just looks like it does usually normally. Okay, and now you solve that equation. So this is a nice simple one to factorize. We're looking for two numbers that multiply together to give you negative 6 and add together to give you the 1 there. So we've only got an x squared term, we've got no other numbers in front of the x squared, so our answer is just going to be x plus 3, x minus 2. Okay? And if we solve that then to get some answers for x, we can have x plus 3 is equal to 0, which gives us the x minus 3 that we found from Desmos. And then if we take x minus 2 is equal to 0 next, so I've just shrunk this down. Looks all right by there. So x minus 2 is equal to 0, x is equal to 2. Okay? Now, just like in normal simultaneous equations then, sorry, not normal simultaneous equations, but the ones you've done before, I should say, you then go on and get your answer for y as well. So what you do is you substitute the value for x back into one of your expressions to get a value for y. Now, the easiest one to use with these questions is always going to be the linear one. Okay, so you want to try to keep it simple. So if we use y equals x minus 1, then that's going to give us y equals minus 3, take away 1, so y is equal to negative 4. Again, we use y equals x, take away 1, so that's going to be y equals 2, take away 1, so I've got an answer of 1. Okay, and then I'm going to pair these up, so this x and y value goes together, and the other x and y value goes together. Remember, if you think back to that graph we looked at earlier on, actually what we're working out, those coordinates, the points of intersection, so it's a good idea, as I'm doing now, just to conclude your answer and present your answers as a pair of coordinates. So that gives us the answer negative 3, negative 4, and 2, 1. So if you rewind the video, you'll see that those are the same as the coordinates we got from our Desmos graph. So minus 3 minus 4 is the one there, and 2, 1. Yeah, okay. And then the 2, 1 is there. Look, so if I go across the 2 to the point of intersection, and that gives me my coordinate of y equals 1. Okay? It's really important you don't confuse them and pair them up the wrong way, because if you do that, then the answer you'd be given would be wrong. You'd be, like I just pointed there, if I paired up minus 3 and 1, I'd actually be giving a coordinate that's not on either graph, so it'd be wrong. So make sure you do pair them up correctly. Okay? Let's do another example now then. Okay, so we're going to look at 2x plus y equals 1 and x squared plus y squared equals 2. So if you draw that in Desmos again, you'll get the following. So x squared plus y squared equals 2 is actually an equation of a circle, which you learn about after IGCSE. And 2x plus y equals 1 is the linear one, which is a straight line, because it's got no powers in the expression. So again, you can see we should be getting two answers. So let's get our expression for y or x to substitute in. So if I start my linear, the easiest thing to do there is if I take the 2x across the other side, I get an expression for y. So y is equal to 1 minus 2x. I'm going to stick a box around that because that's going to be quite important. I want to see what that is and refer back to that at the end of the problem when I work up my y values, remember. Okay, so let's just shrink that and put it there. So now I'm going to take the non-linear expression, so x squared plus y squared equals 2, and I'm going to substitute y equals 1 minus 2x. It's a good idea just to give these little statements like I've written there, just so you are conveying to whoever's reading your work what you're doing, and it also makes you think about the next steps as well. It's a useful thing to do. So we're going to substitute y equals 1 minus 2x into x squared plus y squared equals 2. So we use our brackets effectively. So that's going to give us x squared plus bracket 1 minus 2x close your bracket, squared, equals 2. So I've literally changed that y into 1 minus 2x inside a bracket. Okay? So I've changed it into this thing here. I've just literally just replaced it. Right, so if I expand that bracket now, I know I'm going to get two answers. So I've got an x squared there. I'm going to get an x squared from the bracket expression. So I should be leading towards simplifying that into a nice quadratic with the 3 terms on the left-hand side and a 0 on the right. Okay? So I'm going to have x squared plus, and I'm going to expand this bracket quickly. Okay, using the trick we went through in year 10. So if I square the first term, multiply the two terms together and then double it, and then square the third term. So minus 2x squared is going to be positive 4x squared. Okay? Equals 2. Now it's handy knowing that trick because it just speeds up your algebra a little bit. Alright? So let's just have a quick look at that trick. Alright? If you want to write that rule I've just used there, or the trick I've used, as in algebra, effectively when you're squaring a bracket, what you're doing is you're multiplying that bracket by itself, aren't you? Okay? So a times a gives me the a squared. So that's why I can square the first term to get my first term. Then I would do a times b plus b times a, so which is ab, plus b squared. Okay? So what you're doing, the reason you're doubling that, you're multiplying those terms together and doubling it, is because of the way that expansion of two brackets works. So that leaves us with a squared plus 2ab plus b squared, look. Which is what we did. Squared the first term, squared the second term, multiply the terms together to get ab, and double our answer. Okay? So that's a good little trick worth remembering. So let's just write that up on the side so you can see what I used. So a plus b squared is equal to a squared plus 2ab plus b squared. Alright? But, ultimately, if you don't remember that trick, all you would do is in that line, you'd have 1 minus 2x brackets, 1 minus 2x, and expand it the normal way. Okay? So now let's simplify this. So I'm going to get 5x squared minus 4x. I'll bring the 2 across. So I'm going to have 1 take away 2. It's going to give us negative 1 equals 0. So there's my... Whoop. It's all gone a bit weird there. Let's just shrink these little bits down so give myself some room. There we go. So now we've looked at lots of ways to solve these kinds of quadratic equations. I'm going to do the written method where we multiply the 5 and the minus 1 by each other and separate in turn. But remember, you can always fall back on the quadratic formula if you get stuck. So 5 times negative 1 gives me negative 5. Now I'm going to look for my factor pairs that are going to add up to that middle term. So 1 and negative 5 gives me negative 5. Minus 1 and 5 gives me negative 5. So I'm going to split that minus 4 into 1 and minus 5. So I'm going to split my middle term. So I get 5x squared plus x, take away 5x, take away 1 equals 0. Okay, now we factorize that each in turn. So x brackets 5x plus 1. Then I know I'm going to have a repeated factor, so I've got 5x plus 1 again. So what do I do to 5x to get to minus 5x? I need to multiply by negative 1. So negative 1 goes outside. And then I get 5x plus 1, brackets, x minus 1. So remember that x term, the minus 1, become the second bracket. Equals 0. Okay? So there's my two x values for my two coordinates. So we just shrink that again. Slowly run out of room on this screen. So I'm going to get 5x plus 1 equals 0, which gives me x is negative 1 over 5. So I'm going to convert that into a decimal just to give myself a bit more room. So it's negative 0.2. Nope. Let's just try to shrink that down better. There we go. Stick it over there. And then from my other factor, I'm going to get x minus 1 is equal to 0. So I've got x is equal to 1. And shrink that down. Stick that over there. Oh. So it's going a bit wonky. Right. So then, go back to that expression right at the beginning that I put in a box. So y equals 1 minus 2x. I can just substitute my x values into there. Use brackets effectively to make it easier for you. Stick that into your calculator, and you're going to get y is equal to 1.4. And then the second one, if we substitute x equals 1 into y equals 1 minus 2x. I'm just going to do that over here because I'm really running out of room now. So x equals 1 into there. That's going to give me y is equal to 1. Take away 2 lots of 1. So y is equal to minus 1. Just shrink that and put it under the correct place when I'm working. Okay. And again, we want to write these as conclude our work now and give those two answers, pair the correct x and y terms numbers up, and give our answers as coordinates. So our one coordinate would be negative 0.2, 1.4, and our other coordinate is going to be 1 minus 1. So there we go, 1 minus 1 in brackets, stick it over there, and that's how you'd want to present your solution as well. Okay? Alright? So like I said, by putting them as coordinates at the bottom of those two little columns, splitting up that final process into two columns like that is a good idea, so you don't actually mix up your x and y terms then. Okay? Just put a little bubble around that so you can see it was part of our working out. Right then, one more example. Right, so here's your final example of simultaneous equations with one nonlinear equation. So we're going to start now with the linear again. So 3x plus y equals 4. We're going to make an expression for y, because it's going to be the easiest one to do. We just take the 3x across to the other side, and we get the substitution y is equal to 4 minus 3x. Again, I'm going to draw a box around that, because that's an important one to be able to find in all our algebra at the end of the problem. So I'm going to take the nonlinear one now, which is the xy equals negative 4. And I'm going to substitute that y for 4 minus 3x. So I'm just going to replace the y with a bracket and the expression 4 minus 3x. Close your bracket equals negative 4. Okay, and then again we should notice what kind of equation that is as we expand the bracket. So that square term tells us a quadratic again. And because I would just want that x squared term to be positive, I'm going to take it across the other side, so I'll have 3x squared minus 4x minus 4 equals 0. Okay? Now, I'm going to try there to see if I can factorise that. Oh no, I can't. So there's my 5 seconds or so up. So rather than panic and stress myself out about how I'm going to factorise that into the double brackets, I'm just going to go straight to the quadratic formula, which should appear on the left any minute. And I know then, as soon as I start doing the quadratic formula, I can solve the question within a matter of seconds. Alright, so at this point in the test, you'd be looking into the front of your test and picking out that quadratic formula from the formula booklet. So, where is the formula? There we go. Alright, so we've got x equals minus b plus or minus the square root of b squared minus 4ac is divided by 2a. So we pick out our a, b and c. So a is in front of the x squared, which is 3. B is in front of the x term, which is minus 4. C is the term on its own, so the number on its own, so it's negative 4. Negative b then is going to be 4. B squared will be 16. 4ac is going to be 4 times 3 times negative 4. So that's going to be negative 48. And the 2a is going to be 6. Okay. shrink that down and just stick it there. Alright. I'm also going to work out the b squared minus 4ac bit, the discriminant, just to make it a bit easier. That's just going to be 16 take away negative 48. So that'll be 16 plus 48, which is 64. Just shrink that down and stick that on the bottom there as well. And then I've got my three terms to stick straight into my quadratic formula. So minus b is 4, plus or minus the square root of b squared minus 4ac, which is 64, divided by 2a, which is 6. Alright? So seriously, that method of splitting it up makes it a lot quicker and a lot easier. So that's going to give us 4 plus or minus 8 divided by 6 to get our values for x. So our first value of x is going to be x equals 4 plus 8 divided by 6, which is going to be 2, because 4 plus 8 is 12, 12 divided by 6 is 2. So just shrink those two things down, do a brilliant job of it. Here we go, done. And the next one then obviously is going to be 4 take away 8 divided by 6, okay, which is going to be negative 4 over 6, which will be cancelled down to negative 2 over 3. Okay, I'm not going to write that as a decimal because it's going to end up giving me a long recurring decimal, so I'm just going to leave it as a fraction as negative 2 over 3. Okay, so we're going to take that expression in the box, y equals 4 minus 3x, and substitute our numbers in. So my first value for y is going to be 4 take away 3, that's a 2, so that's 4 take away 6, which is negative 2. Alright, so just shrink that and put that there. Same then with the other value of x. I'm going to go back, use that expression. So y equals 4 minus 3x becomes y equals 4 minus 3 brackets minus 2 over 3. Okay, now you can either cancel down those 3's or whatever you want to do and get the answer of 6, or just stick it all into your calculator and make sure you get 6. Alright. So then remember, make sure you got the x and the y paired up correctly, and then present your answers as coordinates at the bottom of those columns. So our one answer is going to be 2 minus 2, our answer is minus 2/3, 6. That's it, job done. Every single question, I can't stress this enough, every single question is the same. The only decision you're going to have to make is what method you were going to use to solve your quadratic equation. So again, remember my advice. If you take longer than 4 to 5 seconds to factorize it into double brackets, you stop what you're doing, you go straight to the quadratic formula, and you know that within a couple of 30 seconds you'd have answered the question. Okay, right, off you go. I'm going to go now because that beeping sound you can hear in the background is my microwave telling me my dinner's been warmed up. So hope you've had a lovely week, and I'll see you next week, year 11. Bye.